Okay, so today we are going to start module number 1 of advanced manufacturing technology subjects. Okay, so in module number 1, so this is just the introduction part of the non-traditional manufacturing process. Okay, and also we will see some uh, mechanical types of non-traditional manufacturing process. So first we will see what is the introduction part. Okay, so this manufacturing, okay, in the last class also I have discussed about manufacturing, that it is divided into two types. One is the subtractive type of manufacturing and second is the additive type of manufacturing. Okay, in the subtractive type of manufacturing, so as the name indicates, subtract means the metal is removed from the workpiece to obtain the desired shape and size. Okay, for example, all the machining process which you are seeing on the screen, turning, boring, milling, shaping, broaching, slotting, grinding, okay, then abrasive jet machining, ultrasonic machining. So these are all comes under your subtractive type of manufacturing. Okay, and in case of the additive type of manufacturing, means the uh, metal is added to the workpiece to obtain the desired shape and size. Okay, so in your syllabus, there is only subtractive type of manufacturing and it is divided into two types. One is the conventional machining process and second is the non-traditional machining process. Okay. So in your syllabus for this subject, you have to study only about non-traditional manufacturing process. Okay. So first, know the difference between conventional machining and non-traditional machining. So what is the difference between both? Okay, so first see the example. So the example of your conventional machining process is turning, boring, milling, shaping, broaching. Okay, slotting, grinding, etc. So these are the examples of conventional machining process. And non-traditional machining process, the example is your abrasive jet machining, ultrasonic machining, water jet and abrasive water jet machining, then electro discharge machining. Okay, so these are the some examples of your non-traditional machining process. Okay, now what is the difference between both? So in the last class also I have discussed about the difference between conventional and non-traditional machining process. So the first difference and the most important difference is that in this case, in case of the conventional machining process, okay, so there will be contact between the tool and the workpiece. Okay, for example, suppose if you are doing any operation on the lathe, okay, so in lathe there is generally single point cutting tool, and this cutting tool will be in contact with the workpiece for the removal of the material. Okay, like that for the broaching also there is broaching tool, like that for the milling also, so there is milling cutter. Okay, like that. Okay, so in conventional machining, the tool and the workpiece will be in contact with each other during machining action. Okay, but in case of non-traditional machining process, there is no direct contact between the tool and the workpiece. Okay, so this is the first and the most important difference. Now, second difference is that in conventional machining process, much complicated surface cannot be manufactured. But with the help of non-traditional machining process, the complex shape can be manufactured. Okay, so this is the second difference and the most important difference. Now, and the third difference is that in most of the cases, in case of the conventional machining process, so as we know that the tool should be harder than the workpiece material. Okay, but for the machining of the harder material, it is very difficult to do with the conventional machining process due to unavailability of the tool, unavailability of the tool material. For example, suppose if you want to do the machining of, as we know that the carbide is very hard material. Okay, so for that, the tool should be harder than that carbide material. That is your carbide workpiece. Okay, otherwise the tool will break. Okay, so these are the some limitation case of the conventional machining. But case of the non-traditional, so there is no such difficulties because there is no contact between the tool and the workpiece. Okay, so the hardness or the strength of the tool is not an important parameters in case of the non-traditional machining process. Okay, so this is the third difference. And as compared to the conventional and non-conventional, very higher accuracy can obtain in your non-traditional machining process as compared to the conventional machining process. These are the difference. Okay. Now you can see that the main reason for using non-traditional machining are, first is the for high strength alloy, then for complex shape, for obtain higher accuracy and surface finish, then difficult geometry, and fourth is the automation. Okay, so these are the four factors which is responsible for the development of non-traditional machining process. Okay, so if you go into the history, so first the conventional machining process has been developed, and after conventional machining process there is some limitation in to eliminate this difficulties or limitation. So non-traditional manufacturing process has been developed. Okay, so this is developed due to this following factors, that is high strength alloy, then for complex shape, for obtain higher accuracy and surface finish, difficult geometry, and automations. Okay, nowadays I think all of you heard about the different type of material has come. Okay, like smart material. Okay, then super alloy, then this one composite material. So this type of material has come into the existence. Okay, which has very high strength. Okay, generally this material are classified into difficult to cut material. Okay, that is why it is not possible in case of the conventional machining process. So there is need of the non-traditional machining process. Okay, so I think the difference between conventional and non-conventional you have understand, and why we need non-traditional machining process, this also you have understand, I think. So if you have any doubt till here, then you can ask. Is there any doubt?
No, sir.
Okay, now we will see the classification of non-traditional machining process. Okay, so you can see on the screen. So the classification of non-traditional machining process is carried out depending on the nature of the energy used for material removal. Okay, so generally this classification is done on the nature of the energy used. Okay, so first is the mechanical process. So here generally the mechanical actions take place for the removal of the material. Okay, so in mechanical process, four types of non-traditional machining process occur. So first is the abrasive jet machining. Okay, and the short form is AJM. Then second is the ultrasonic machining, short form is USM. Then third is the water jet machining, the short form is WJM. And the last is abrasive water jet machining, and the short form is AWJM. Okay, and all this process you have to study in detail because it is given in your syllabus. Okay, so these four types comes under the mechanical process. Okay, and one thing you have to remember that in abrasive jet machining, in ultrasonic machining, and in abrasive water jet machining, so in this three type of machining the use of the abrasive particle is done for the removal of the material. Okay, now coming on to the electrochemical process. Okay, so the material is removed by the help of electrical power plus the chemical used. Okay, so in this case you can see that uh, uh, electrical power plus the chemical is responsible for the removal of the material, and it is sub classified as electrochemical machining. Short form is ECM. Second is electrochemical grinding. Short form is ECG. And next is the electrojet drilling, and the short form is EJD. Okay. So in your syllabus only you have to study this part. That is your electrochemical machining. That is ECM. Okay. And in this machining there is some numerical part. Okay. Means what will be the operating voltage and what will be the ampere factors. Okay. Then what will be the MRR. So this you have to study. Okay. Then coming on to the electrothermal process. Okay. So here by the help of the electrical power, some thermal, that is the heat is generated. Okay. And with the combination of the electrical power and heat, the removal of the material takes place. Okay. And it is subdivided into electro discharge machining, that is EDM, then laser jet machining, LJM, and electron beam machining, EBM. Okay. So in your syllabus you have to study all this three machining process. Okay. And last is the chemical process. Okay. So in chemical process, chemical milling and photochemical milling. So in chemical process only you have to study the what is the chemical process for the removal of the material. Okay. So this completes your syllabus. Not syllabus, near about 80%. That is from module 1 to module 5. Okay. So in this case you have to remember that this non-traditional machining is classified according to the nature of the energy used for the material removal. Okay. So first, or in the first module, we will study about mechanical process. Okay. That is non-traditional machining. Okay. Non-traditional machining which is comes under the mechanical process for the removal of the material. So first we will see what is abrasive jet machining. Okay. So the short form of abrasive jet machining is AJM. Okay. Wait 1 minute. Before starting this abrasive jet machining, I want to show you what is the abrasive particle. Okay. Then you can understand in better way. So 1 minute. So just I am going to show you the abrasive particle. Okay. So see in your screen. So this is the figure of the abrasive particle. So this abrasive particle is very, very small in size. Okay. And if you see one abrasive particle, so in one abrasive particle, many sharp edges is there. Okay. Which is responsible for the removal of the material. So just I'm going to show you the microscopic view of one abrasive particle. Okay, now see here. So this is the microscopic view of one abrasive particle, and the size of this is in micron. Okay, so either it can be 1 micron, 2 micron, 10 micron, like this. Now you can see that these have very sharp edges, like this one. Okay, this part, you can see here at the bottom also, this part, and at the top. Okay, so these sharp edges is generally responsible for the removal of the material. Okay, so this is known as my sharp edges. Okay, and this sharp edges acts as a cutting tool. Okay, so we can say that the abrasive particle is one type of multi-point cutting tool because it has more than one sharp edges. Okay, so in the abrasive particle, so have you seen how the abrasive particle look like? Okay,
Yes, sir.
so now we will start the abrasive jet machining. So in case of the abrasive jet machining, this abrasive particle is used in huge number. Okay, so in case of the abrasive jet machining, the short form is AJM. Okay, so in abrasive jet machining, the abrasive particles are made to impinge on the work material at a high velocity. Okay, so the jet of abrasive particle is carried by carrier gas or air. The high velocity stream of abrasive is generated by converting the pressure energy of the carrier gas or air to its kinetic energy, and hence high velocity jet is obtained. The nozzle directs the abrasive jet in a controlled manner onto the work material, so that the distance between the nozzle and the workpiece and the impingement angle can be set desirable. The high velocity abrasive particle remove the material by micro cutting action as well as brittle fracture of the work material. Okay. This abrasive particle, okay, are made to impinge on the work material. Okay, so as you can see in this figure, so this is your work material and this is the nozzle, and from the nozzle very high velocity of the abrasive particle comes out from the nozzle. Okay, now how this very high this abrasive particle is mixed with the compressed air. So as we know that in compressed air, okay, or you can say that the kinetic energy is very high. So when it will mixed with the abrasive particle and the compressed gas, so the abrasive particle will increase. Okay, and when very high amount of kinetic energy will strike on this workpiece material, the help of the sharp edges of the abrasive particle, okay, the material is removed by the action of micro cutting or brittle fracture of the workpiece. Okay, so this is how the material is removed. And you can see that there is some parameters, that is high velocity abrasive jet are in the range from 150 to 300 meter per second. So you can see that very high velocity is generated. Okay, and this is the nozzle tip, and from the nozzle tip the abrasive particle with high velocity abrasive jet of air comes out. And the diameter of the nozzle, that is the inside diameter, here it is written as di, I for the internal. So the inside diameter of the nozzle is 0.2 to 0.8 millimeter. Okay, and this is known as my standoff distance, and the short form of standoff distance is SOD, that is your standoff distance. So standoff distance means the distance of the nozzle and the distance of the workpiece. Okay, so this distance is known as my standoff distance, and the standoff distance generally lies in between 0.5 to 15 millimeter. Okay, so this is how the abrasive jet machining works. Okay, now in abrasive jet machining, generally the abrasive particle of around 50 micrometer grit size. Okay, grit means that is one, you can say that one abrasive particle is known as grit. Okay, so the size of the abrasive particle are near around 50 micrometer, means very very small. The particle of sand, okay, if you take the sand particle, okay, so actually the diameter of sand particle is in millimeter something, okay, that is 0.01 millimeter, like that. But in case of the abrasive particle, it is very smaller than that. Okay, and it is around 50 micrometer, so it is very very small. But every abrasive particle has multi-edge edge, okay, and this multi-edge acts as your multi-point cutting tool. Okay, and this abrasive particle impinged on the work material at a velocity of 200 meter per second, okay, from a nozzle of internal diameter of 0.5 millimeter with a standoff distance of around 2 millimeter. Okay, so you can see that in this figure, this is the range given. Okay, so based on the material and based on the nozzle internal diameter, this standoff distance changes. Okay, but it should not go beyond 15 millimeter. Okay, so the kinetic energy of the abrasive particle would be sufficient to provide material removal due to the brittle fracture of the workpiece or even micro cutting by the abrasive particle. Okay, now what is brittle fracture? Generally this brittle fracture occurs generally on the brittle material. Now what is brittle material, anyone can say, or you can give the example.
So brittle
Hmm?
example is glass, sir. So which breaks
Glass.
easily, which
Means the deformation is very very less, you can say. Okay, means for example, if we see the stress and strain diagram of the glass, so there will be very very less deformation. So if the deformation increase, so it will break. Okay, so this type of material comes under the brittle uh, material types. And the next example also you can take this one, titanium. Okay, so titanium is also one type of brittle. Okay, means it will break but it will not bend. Okay, and if you take the mild steel, So the mild distill comes under the ductile type of material. Okay, the best example of the mild distill is the construction rod. Okay, so while making any buildings, okay, the rod is used. So this rod is really made of your mild steel. Okay, that is why this mild steel can be easily bent in any shape. Okay, means there will be much deformation. So if you see the stress and strain diagram of the ductile material, there will be much deformation. Okay, so generally the abrasive jet machining is applied for the brittle material. Okay, so in case of the brittle material, brittle fracture is done with help of the abrasive blade, and due to this brittle fracture, the material comes out from the workpiece, or even by the micro cutting of the abrasive. Okay, so what happened when the abrasive fall on the surface? So this sharp edges uh, goes inside the workpiece, and and a small cut is made. Okay, so this is known as my micro cutting. Okay, like your knife. Okay, so when we cut something with the knife, so the knife will penetrate into that uh, material like that. In the same case, the abrasive particle will penetrate inside this workpiece. Okay, when it penetrates inside this workpiece, then it is known as your micro cutting. Okay, so this is the just the introduction part of the abrasive jet machining, that how it's work and what are the parameters which are used in the abrasive jet machining part. Okay, now the total equipment. So this is the total abrasive jet machining setup. Okay, so first you can see that it is the air compressor. Okay, because this is the most important part, because the abrasive particles uh, will be mixed in the compressed air. So there will be one air compressor. So this is the air compressor. This is the turn valve. This is the pressure control valve, dryer, then filter. Then this is the mixing chamber. This is the abrasive feeder, and it is where the abrasive particles and compressed air mix. Okay, so this is mixed in a electromagnetic shaker. Okay, and from this pipeline, it will goes into the nozzle. Okay, and generally this is your chamber, and this is the table, and above the table and you can move the workpiece with the help of this table, and here the exhaust gas goes out. Okay, and some abrasive particles will be collected at the bottom of this chamber. Okay, so this is your AGM setup. So okay, in air compressor, and compressed air at a pressure of around 5 bar is used as a carrier gases. So that is okay, and this compressed air then goes out. Now gases like CO2, nitrogen can be used as carrier gases, which may directly be used from the so so in the cylinder it can be your compressed CO2 gases or nitrogen gas, and this gas goes to the air compressor, and again it is compressed till 5 bar. Okay, and the oxygen is not used as a carrier gaseous. Why? Because you can see this figure. Hmm. Hmm. So when the abrasive particle will impinge at this part, okay, so here also very high amount of energy will be generated. Okay, that is the heat energy, because this abrasive particle contains kinetic energy, and when it will fall on the surface of due to this heat, the surface of this uh, workpiece will get heated. Okay, and as we know that if the surface is heated, so if the oxygen fall here, then the oxide layer will fall. Okay, so when the oxide layer will form, so it will prevent from cutting, because the oxide layer is hard. Okay, so here if the oxide layer will form, then the cutting action will decrease. That is the material removal rate, that is MRR, will reduce. Okay, that is why we can't or we cannot use oxygen as a carrier gases. Generally, CO2 gas is used or nitrogen gas is used. Okay, and mostly nitrogen will be easier as compared to CO2, because in atmosphere, in air, as you can see that in air, 78% gases is your nitrogen. Okay, not 78, I think it is 71 or 70%, but it is more than 70. Okay, and only 21% is your oxygen, and remaining it is the other gases. So that is why from the air, the oxygen can be extracted in huge amount as compared to the carbon dioxide. Okay, now, so this is the pressure control valve. So according to the material, that is the strength or the tensile strength of the material, so the pressure has to be used. Okay, and there is the dryer, because uh, in gaseous some amount of water vapor is also there, so we have to remove the water vapor. So the water vapor is removed with the help of this dryer. Okay, and again it is one type of filter, so that only the gaseous goes into the mixing chamber. Okay, and this is the most important element. Okay, so first, here at the top you can see that it is the feeder where the abrasive particle is stored. Okay, and this is the mixing chamber where the abrasive particles fall here, and also the compressed gas from here goes inside it. Okay, so for proper mixing of the abrasive particle with the compressed air, we are using the electromagnetic shaker. Okay, so as we know that it is one type of shaker, so that it will vibrate with some amplitude and frequency. Okay, so when it will vibrate, so the mixing of the abrasive particle with the compressed air will be uniform. Okay, that is why we are using the electromagnetic shaker part. Okay, then from this, that is the outlet of the mixing chamber. So at this pipeline you can see that the abrasive particle as well as the compressed gas goes out from here. Okay, and you can see that here it is the electromagnetic on off valve. Okay, because uh, due to this pipeline also, okay, we have to keep the abrasive particle and the compressed air in a proper ratio. That is why one additional valve is used here, that is the electromagnetic on off valve. Okay, so that the ratio cannot be changes, and again it will goes into the nozzle part. Okay, and from the nozzle it will impinge on the workpiece. So this part that is this diagram is shown here. Okay, shown here. Okay, now you can see that generally the machining action takes place in case of abrasive jet machining in a closed chamber. Okay, why? Because if it is open chamber, so there will be some operator. Okay, so when the very high amount of compressed gas with the abrasive particle will fall here, so it will goes into the atmosphere also, and if it is inhaled by some operator, so this will be then there will be some problems in breathing. Okay, and some cut will be there, like that. That is why uh, this abrasive jet machining is done in a closed chamber. And one disadvantage of abrasive particle is that it cannot be used re again and re again. Okay, only it can be used one or twice. Why? Because uh, when it is used here, then the sharp edges is broken into the small particle. Okay, so when the sharp edges is broken, so it is not responsible for cutting action in the next step. Okay, that is why the abrasive particle cannot be reused again and again. Okay, I think that time is completed. So in the next process, we will study about the abrasive jet machining setup once again in detail. Okay, so all of you switch on the video for attendance. Do it fast. Rishabh, Naseeb, Subankar. Subham Banik, switch on. Do it fast. Okay, so your attendance has been taken and be ready for the next process. Okay, all of you.
Thank you, sir.